So in reference to exponential decay, there is a terminology formally phrased as radioactive decay. And one way is basically the same type of differential equation. One way of writing down this differential equation for radioactive decay is explicitly writing that constant. Suppose you have a positive constant here called positive k, and so we write negative of that positive number, so making sure that this parameter here, with this assumption, negative k would be a negative number, right? So we could write something like minus k times q. So let's say q denotes quantity, mass, volume, weight, q as a function of t. And so we can write this differential equation basically saying that the rate of change of that mass of the amount of material is equal to minus k times q. There is an initial condition q sub 0. Using separation of variables, we can find the solution of this linear differential equation, and that solution, assuming that is starting at t sub 0, the solution has this particular form. So in this context, when we're describing things that are functions of time but they decay exponentially, it is also pertinent to look at the calculation of the so-called half-life, right? So assuming that q is an exponential function of t, and assuming that we have an initial condition, initial amount of material q sub 0, the so-called half-life is the time that is required for the material to become half of what it was, right? So is the time, say, tau units after the initial time t sub 0. So the amount of material at time t sub 0 plus tau is the initial condition divided by 2. So once we have an expression for q of t, evaluating that expression at this particular time t sub 0 plus tau leads to an expression in which we can equate q0 e to the minus k tau. We can equate that to that quantity q sub 0 divided by 2, and then we can solve for tau. And if we solve for tau, then we would find this so-called half-life. And so in this case, these calculations are not too difficult. Tau here will be equal to natural log of 2 divided by that constant k, right? So remember that constant k comes from how we were writing q prime equals minus k times q.